Buongiorno. That's Italian. I am multilingual. Right, what I'm going to look at now is fractions when we add them, subtract them, multiply and divide them. Okay, adding and subtracting follow the same first steps and first technique. Multiplying is nice, and division is, I've got a little saying that I go with it. Others have their own little saying, and we'll get to that one. So this is over a few pages within that booklet, and I think there's at least one example of each of them. Some of them do start with mixed number fractions, so we'll have a little look at that as well, just so you know. Right, so I'm going to start off with question 1 in the booklet. But I'm going to use the same two fractions to begin with and just do it every single time with the different operations. With these questions in the booklet, you can see that it already has the answer for you. So it's covering quite a lot of bases to do with, can you add and subtract with them? Can you do simplifying? Can you do any converting, particularly if it's mixed numbers to improper or the opposite way around? So we'll start off with, we've got 3/4, add 4/5. Okay. Whenever you are adding or subtracting fractions, we need to have a common denominator, because what we're trying to join is fractional parts. So for example, if you had half a cake, okay, and then your mate says, I'll swap you with 1/4 of a cake, you're going to be a bit hard done by there, because your slice is massive and their slice ain't. Okay. Additionally, when you literally add them together, we've not then got 1/2 or 1/8 or whatever. We've got then something different. So we've got to look at then how and why we've got this. So the first thing we want to do is we want to have common denominators, which means the same number at the bottom. I do that by multiplying those bottom numbers together. Okay, so 4 multiplied by 5 is 20. So there's my common denominator. Then what I want to be able to do now is I want to now multiply both the numerators by the same amount that that denominator's been multiplied by. So this fraction here was just multiplied by 5. So that means then the 5 and the 3 need to be multiplied together, which gives me 15. This fraction over here, the bottom value was multiplied by 4. So again, the top number then needs to be multiplied by 4. So this is referred to a lot as the kiss-kiss method, where you kiss your bottoms and then you kiss your diagonals, and then that gives you then equivalent fractions for both. Okay, which gives us then 16. Now that we've got a common denominator, what we can now do is add those together. So 16 add to 15 gives us 31 over 20. Okay, so now we can see that we have got an improper fraction because it is heavy on the top over the denominator at the bottom. Okay, so what we're going to look at now, I'm going to do 20. Turn my pen on. 20, 40, 60. Okay, so I can see that if I've got 31, it falls in here somewhere. So that means I've got at least one whole time that my denominator goes into my numerator. So I've got one whole time. I've got 31 pieces to play with. I've used 20 of them. So I'm going to subtract off that 20, which leaves me 11. Those remainders are then what goes on top. What I'm now going to look at is, can I simplify my fractional part of the question? 11 is a prime number. It doesn't go into 20 on its 20 times tables, so then I leave it. And by looking at the booklet as well, I know that then it matches in with what I need it to match in with. Okay, so we're all good. Okay, so right, this time we're going to look at subtraction. I'm going to use the same two fractions. I'm just going to swap them around this time. Let's get rid of that bit as well. So I have got 3/4. It's gone off the page, hold on. I don't know how you use this, can you tell? Right, delete. Okay, so I've got 3/4. Is that going to go on the page? I don't want 3/4 first, do I? Right, 4/5. Subtract 3/4. Same first process is I need these to be the common denominator. So again, I'm going to do my bottoms, gives me 20, subtract, and then 20, 4 4s are 16, and then 5 3s are 15. This time I just need to then subtract them. 16 subtract 15 gives me 1/20, and then I've got my final answer. Okay, so the adding and subtraction follows that same pattern. Get common denominators, which then means your numerators need to be equally multiplied up to then give you equivalent fractions to your starting two. But all you then do is just subtract off your denominators. Right, now we're going to look at multiplying. Multiplying, in theory, is meant to be a harder skill than adding and subtracting, but it's not really. For this, all we've got to do is follow this. Numerator multiplied by numerator, so top multiplied by top, and then bottom multiplied by bottom. So for this, I would do 4 multiplied by 3 over 5 multiplied by 4. So 4 3s are 12, 5 4s are 20, and then that's my answer. But what I'm going to look at now is then simplifying that. So I've got 12 and 20. They're both on the 2s, but I also know they're on the 4s. So I'm going to go for a higher common factor, so HCF, because then I just have to do less simplifying. It doesn't matter if you divide it by 2 and divide it by 2 again, or dividing it by something else. It's absolutely fine to do that. But I'm going to divide both bits by 4, which gives me 4, 8, 12, 3 over 20 divided by 4 is then 5, so 3/5. Okay, if we looked at that, then doing divide by 2, divide by 2 again, you'd have 12 divided by 2 is 6, 6 divided by 2 is 3, 20 divided by 2 is 10, 10 divided by 2 is 5. We get the same answer. Happy days. Right, last one we're going to look at then is what I refer to as my mate Kif. Okay, not Keith, Kif. Okay, so Kif stands for keep. Oh, I've already put the I. Inverse, and then flip. Some teach it in regards to. So I can move this down. Some refer to this as KFC, keep, flip, change. Personally, I just look at it as keep, inverse, flip, and I'm going to show you why. So I'm going to nick a question out of the booklet. So this is 3 over 8 divided by 7 over 12. So 3/8 divided by 7/12. So Kif, keep, means that this fraction I'm going to keep exactly the same. Inverse means to do the opposite. So instead of dividing, I'm going to do the multiplying. And then flip means I'm going to turn the fraction upside down. So the numerator is now going to go at the bottom, the denominator, and then the denominator is then going to go above, which then becomes my numerator. Okay, so I've kept, I've inverted, and then I've flipped. So keep, inverse, flip. That's my mate Kif. Now that we've got a multiply sign, I can now follow the same pattern as what I did previously, which is 3 multiplied by 12 over 8 multiplied by 7. So 3 lots of 12 gives me an answer of 12, 24, 36 over 8 sevens gives me an answer of 56. What I've got now is 2 even fractions. Okay, both of them I know are going to be on the not on the 3 times table, on the 2 times tables. There might well be higher common factors. Okay, but I'm going to go with the 3s for the time being. Not the 3s, the 2s. Why do I keep saying that? So half of 30 is 15. Half of 6 is 3. Add them 2 answers together gives me then 18. Half of 50 is 25. Half of 6 is 3. So 25 add 3 gives me 28. Again, I've got 2 even numbers left, so I'm going to half these again. Okay, so should just put this on. Half of 18 is 9. Half of 28 gives me 10, 14. Now I've got to that point, I've then got nothing else I can divide by because 9 only has factors of 1, 3, and 9. 14 has 1, 2, 7, and 14, and neither of them are then shared. So then that one's done. So keep, inverse, and flip, and then it matches up. Right, I'm going to do one more, just in regards to division, but this time division when you've got a mixed number fraction. My brain's gone numb. Too much Easter sleep, I think. So I'm looking at question 6b in the booklet. So the first thing I've got then is 2 1/4 divided by 3 1/2. Okay, it's telling me that my answer needs to come out as 9/14. So you can see that my answer effectively is just getting rid of any of that mixed numberness and just going back to just a normal fraction. The way in which I would do this is I would turn these fractions into improper fractions. So 2 whole ones represents 1 whole one, 4/4. 2 whole ones, another 4/4, plus then another quarter. Okay, so what I've now got here is, move this over for you. What I've now got then, if I count my quarters up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 quarters. On the other side, I've got 1, 2, 3 and a half. So if I split each of my whole ones into halves, I've now got 1, 2, 3, 4, 5, 6, 7 halves. So I've got my 7 halves here. Now I've got my improper fractions. I'm going to go back to my mate Kif. Keep, inverse, flip. So 9 over 4 multiplied by 2 over 7. So now I've got top multiplied by top over bottom multiplied by bottom. 9 lots of 2 is 18. 4 multiplied by 7 is equal to 28. Now I need to simplify it because you can see that my answer does not match this answer that it wants it to match. So I'm going to half them because they're both even. Half of 18 is 9. Half of 28 is 14. Bing, bang, bosh. We've done it. So for these ones, I find that the easiest way is convert them into improper fractions then do your normal method that you know, keep inverse and flip, and then simplify where applicable. Okay, I hope that helped. Enjoy. Laters.